welcome back to geometry. These two questions are just a little reminder about quadrilaterals. Sounds like I have to turn down volume. Okay, what we recognize about both of these is that the sides of a parallelogram are going to be equal, so I would set these equal to each other and solve, with x being 13/7, so that's a lovely number. So when we have something like sevens, we really should not be making it a decimal, because that would be an approximation. Second thing that we have is when these angles are equal, if these two angles are also equal, it would then be a quadrilateral. So we set 6x equal to 4x plus 24, and x equals 24. So our objective for 10.2 is to be able to name and identify a couple different types of arcs, and then use information about arcs to solve different problems. So the most common type of arc is called a minor arc. And a minor arc, whenever we label an arc with just two letters, so an arc is a part of a circle, and if we label it AB, we have to go around the short direction. It's assumed that we're going the shortest way possible as an arc, so that would be this 50-degree arc over here. If we wanted to go the other way, we would have to use a third letter in the middle to be able to say, I want to go from A through D to get to B, and that is going to be a major arc. Major arcs are arcs over 180 degrees, and minor arcs are less than 180 degrees. If we have an arc that is exactly halfway, it would be a semicircle, and that's 180 degrees. And in that, we could go both directions. We could label it with three letters to say, hey, I want to go this way. But we have minor arcs, less than 180, major arcs, greater than 180, and semicircles. Now, we can actually find the measurements of those, knowing that the diameter cuts a circle in half. Then we know that half of that circle has to be 180 degrees. So we know that this side over here has got to be 180 degrees. And if this side from R to T could also be 180 this way, then RS is going to be 110 degrees. So the central angle and the arc have the same measurement if we measure them in degrees. Then if we're looking for this one over here, RTS, well, that's 360 minus the 110, because we're not going to go the short way, we're going to go the long way. So that angle is, that arc is 250 degrees. RST, well, has to be a semicircle. That's 180 degrees. Starts and ends on a diameter. Just like we have been able to add segments, add angles, we get to also add arcs. So as long as we have two adjacent arcs, we can add the two arcs to get the measure of the larger arc. In this case, I have arc ABC that I want to find the measure of, and I have arc AB, which is labeled as 110 degrees, and BC is labeled as 120, so I add those together, and the full measure of arc ABC is 230 degrees. Remembering that the arcs are congruent to the measure of the angles, GE, well, that's the sum of these two, so that's going to be 40 plus 80. So that's 120 degrees. To go from G to F through E, that's 120, that's 110. So that's going to be 230 degrees. GF, well, if I'm going GF, I have to go the short way. Remember, if I only have two letters, must go the short way. So that one I'm going to find 360 minus the part that I already found going the other way. So that is going to be 130 degrees. Okay, we can have all kinds of information on circle graphs. And on those circle graphs, we're still looking at the measures of the arcs compared to the central angles. Those are the same. So arc AC includes inventors and musicians. So I would add those two together. And I'm going to get 137 degrees. ACD, I am specifically going through C to get to D, so now I'm including inventors, musicians, and athletes, so I would be adding those three up. I already have the 137 plus 83 is going to be 220 degrees. ADC, ADC, that means I'm going to include actors and other and athletes, so that would be 79 plus 61 plus 83, so that's going to be 140 243 degrees. E going through B to get to D. That means I'm going E to D, but the long way. The easiest way to get to that is 360 and subtract the other category, and that is 299. Okay, so whether it is on a circle graph or other circles, the same rules apply. Major arcs, minor arcs, and semicircles, and finding the measure of those angles. If we have just a few pieces of information on the circle, we can usually find the missing parts. So if I know that I have all of these, this is 260 degrees, that means this guy is going to have to be 100 degrees. A little bit of information can go a long ways. TQ, well, I'm going the short way, so this is a minor arc. And that minor arc is 120 degrees. But if I go QRT, now I have to go the other way. So that one is going to be a major arc. And the easiest way to get there is 360 minus 120, so that's 240 degrees. TQR, T going through Q to get to R. Well, when I add those two things up, I get 180 degrees. That makes that a semicircle. QS. QS, I have to go the short way because they didn't label a third part, so that has to be a minor arc or a semicircle. And in this case, because it's 160 degrees, it is a minor arc. TS must go the short way, that's minor. And that is 80 degrees. R through S to T, R through S to T, when I add those two things up, I get 180 degrees. Again, that is a semi-circle. Okay, arcs are major arcs, minor arcs, and semicircles. If two circles have the same radius, they have to be congruent. That's all I need to know about the circles and their congruent circles. I also can have, on the same circle, I can have two minor arcs that are congruent. Their angles have to be congruent. Or I can go the other way and say if I know the angles, then the arcs have to be congruent. So are the red arcs congruent? Well, both of these arcs are on the exact same circle. They are 80 degrees, so that means the arc is 80. And this arc is 80. And since they're on the same circle, they have to have the same radius. So yes, these guys are. Even though both of these two arcs are 90-degree arcs, are they congruent? They're not congruent because they are not on the same size circles. I see tick marks that tell me that the radius are the same, the angles are the same, so these are congruent arcs. Must be either on the same circle or two congruent circles with the same angle. So here we have two congruent circles, so yes, these guys are congruent arcs. Here we do not have congruent circles, so these are not congruent arcs. Okay, so in the end, all circles are similar. They're not all congruent, but they are all similar. Your homework will be on Google Classroom, and we'll have a Google Meet on Wednesday at 9 o'clock, and have a good day.